Hi, we're going to go over the outcome in 9.1, and that's demonstrating the understanding of powers of integral bases and the whole number exponents, which basically means I'm going to go through the checklist with you right now, which basically means you need to know what is a power. And here are all the things. You need to label the base, the power, the exponent, write it in repeated multiplication, know what a power represents, know what those brackets mean, and the value, whether it's going to be negative or positive, and evaluate them and use the order of operations. You're also going to have to know the powers of 10 and the zero exponent. And you have to know how to solve exponents and powers using order of operations. Then on our checklist, you're going to have to be able to know that and then combine it with the exponent law 1 and exponent law 2. And our ultimate goal above an A would be I know my rules, I know my laws, I know what an exponent and a power is, but then I also can look at a friend's work and identify where they went wrong or how I can fix it and where to go. So that's our ultimate goal. But we'll start off by understanding what is a power. So a power is, we can use powers to show what repeated multiplication means. 3 to the power of 5 means 3 times 3 times 3 times 3 times 3 5 times. It does not mean 3 times 5. This is what's the form of repeated multiplication, and it's also known as expanded form. When you are, this entire 3 to the power of 5 is known as the power. That's the name of it. This is called the base. And this right here, the 5, is the exponent. And when you want to know the answer of 3 to the power of 5, the answer itself is called the standard form, which in this case is 243. So to review that, if I have 2 to the power of 3, 2 is your base, 3 is your exponent in an expanded form, or as in repeated multiplication. That means 2 times 2 times 2, which is like saying 2 times 2 is 4 times 2 is 8, so which is much different than 2 times 3. So do not mistake a power of multiplication. So when we move on to the next thing is, okay, that's all fine and dandy, but how do I use my calculator? That is the question that everyone wants to be able to do. So if I have the example of 4 to the power of 6 in my calculator, I'm going to type in the number 4. Then in your calculator, your buttons on your calculator are going to look like an X with a little tiny Y, a Y with a little tiny X, a little arrow up key that's like that, or an X with a little box above it. These on your calculator are the exponent buttons. Okay? And then you hit the 6 for the power. So then you will give you the answer of that in your calculator. So just take a moment and find out what is the button on your calculator look like, because everyone's different. Sometimes you have to hit that little second function. It's usually an orange button on your calculator, and you have to hit that, but usually these are your main keys for your calculator. So then we ask, what is the importance of brackets? So if I have the question 3 to the power of 4, sorry about that, that means I have a base of 3, and which means it's 3 times 3 times 3 times 3 4 times, which if you use your calculator and you go 3 to the exponent button of 4, you'd get the answer of a positive 81. All right, but if I go 3 to the negative power of 4, these brackets right here, these brackets, those brackets mean everything in here belongs to that power of 4. So then you need to say your base now becomes a negative 3. So that means I have a negative 3 because these brackets say, hey, everything in here belongs to that power of 4. So it means negative 3 times negative 3 times negative 3 times a negative 3, which we know because when we reviewed our integers of rational numbers unit, we learned that 4 even exponent, or 4 even negative signs equals a positive 81. All right, but if I go a negative 3 to the power of 4, and there's no brackets, this exponent applies to the number right in front of it. So it says, hey, my base is just a 3. So that 3 directly in front of it belongs to the exponent. So that means this, we can't forget about this negative sign. So it goes negative times 3 times 3 times 3 times 3. So that will give us, if you put that in your calculator, negative 81. So if I also have a negative times a negative 3 to the power of 4, that means the same as this guy up here. However, we got to make sure that we apply that negative sign. So that's going to be my base is still going to be a negative 3, but I'm going to go this negative sign right here, negative times a negative 3 times a negative 3 times a negative 3 times a negative 3. And if we count all of our negative signs, 1, 2, 3, 4, 5, that is an odd number, which equals a negative 81. So in summary, the base of whatever is inside the bracket, and if there are no brackets, the base is the number directly in front per se of the exponent, and do not include the negative sign until after when you apply it to the answer. All right, so that's the importance of the brackets. So let's look at this again. Is negative 5 to the power of 3 and negative 5 to the power of 3. Are those the same? Okay, I'll just give you a moment to think about that. Remember, the brackets mean everything in here belongs to that power of 3. So if I have negative 5 to the power of 2, it equals negative 5 times negative 5, which equals a negative and a negative. When a bad thing happens to a bad person, it's a good thing. We want bad things happening to bad people in math. So that makes sure that we have a positive answer. And if we have a negative 5, now remember that sign is applied after, so it's 5 times 5, which is then a negative 1 or negative 25. So if we look that up here, if we go negative 5 times a negative 5 times a negative 5 will give us an answer of a negative 125. And this one here will give us an answer negative of 125 as well, but we need to understand how we got that answer. So that's the importance of the bracket. So just a little math humor here for you. Say, hey, Cube, do you consider yourself being religious? I believe there are higher powers than us, if that's what you mean. X to the power of 3, get it? Higher powers of x to the side squared. So just a little math humor for you. The next thing on our checklist is we need to know the powers of 10 and the 0 exponent. So if we went through that, we would say, if I went 10 to the power of 0, put that in your calculator, you'll get 1. 10 to the power of 1 is 10. 10 to the power of 2 is 100. 10 to the power of 3 is 1,000. 10 to the power of 4 is 10,000. So you'll notice the pattern connection here of whenever we use a base of 10, the base of 10, it tells us how many zeros are in standard form. So if you notice the 10, there's 0 zeros. After this one, there's 1. And it also tells us the place value of that number. So when we want to, anything to the power of 0 is always 1, but you have to be really aware of your bracket rules. So if I have 2 to the power of 0, that means it's equal to 1. If I have, now remember we have to apply our bracket rule. So if we have negative 2 to the power of 0, that is also equal to 1. Because those brackets mean everything in here belongs to that power of 0, so that will equal 1. Now if we have a negative 2 to the power of 0, remember this exponent only applies to this 2, so we need to apply the bracket rule. So our answer is going to be a negative 1. So we need to be aware of the law of that and also our bracket rules. So then we have to be able to, we can write the numbers as a power of 10. What does this mean? It basically means scientific notation as well. Sorry, I just moved my computer there. So if I have 500, what that means, I have 5 times 10 because 10 tells us it's hundreds. And how many zeros are after the 5? 2. If I have 2,000, that will say 2 times 10 to the power of how many zeros? 1, 2, 3, because it's in the thousands. I have 2 numbers in the thousands, which is right here. If I have 5,432, I have 5 times 10 to the power of, what place value is that? 1, 2, 3, power of 3. Plus, I'm going to add it to 4 times 10 to the power of 2, plus 3 times 10 to the power of 2, plus 2 times 10 to the power of, now, how many is the place values of, sorry, this isn't 1, 0, because 2 times 1 is 2. What if I have also sometimes in your high school maths or chemistries, rather than when you're dealing with really big numbers or really small numbers, they're going to use scientific notation. So rather than writing, let's say I have 542,000, if I wanted to write that using the power of 10, I'm going to go 5.42 times 10 to the power of how many place values? 1, 2, 3, 4, 5. For a little shorter version of that. Just think of it as how many jumps you made. 1, 2, 3, 4, 5 jumps to get to there. So there's your place value. You can also do it the other way. What if I was given 5 times 10 to the power of 6 plus 4 times 10 to the power of 5 plus 9 times 10 to the power of 2 plus 3 times 10 to the power of 1 plus 7 times 10 to the power of 0. How would I write that in standard form? Well, I would take 5, and how many place values are after it? 6. I have a 4 with 5 after it. How many do I have of 4? Any? None. 3? None. 2, I have a 9. 1, I have a 3. And 7, that should be a 0. Gosh, I have a 7. So you can do it either way of place a value. So that is understanding the power of 10. So the next thing on our checklist is order of operation using exponents. So we're just a review of your order of operation. You can use the acronym please excuse my dear Aunt Sally, sometimes because parentheses is another word for brackets. We here use, we can use PEMDAS or for parentheses, or we here use also BEDMAS. But either way, you need to remember that it's brackets or parentheses, then exponents, and division and multiplication or multiplication and division, whatever order it comes from left to right. So it's like reading a book, whatever comes first from left to right in your equation question, and then addition, subtraction. So here's some review of some language that you might see in your questions. So let's go into some examples of order of operation, because this is a review of a previous outcome and we've been all doing order of operation. So if I have 3 to the power of 3 plus 2 to the power of 3. All right, so that basically means, according to the order of operations, we have to perform this exponent plus this exponent. So this exponent right here means 3 times 3 times 3. All right, which equals 27. So I'm going to take 27 plus, what is the answer of this? This means 2 times 2 times 2, which equals 8. So we're going to put that answer of 27 plus 8. So 27 plus 8 equals 35 is your answer. So making sure you're using the order of operations. So if we go 18 squared plus 5 to the power of 0 to the power of 0 divided by a negative 5 to the power of 0. Don't let this one trick you. According to BEDMAS, we do everything in the brackets, right? So we go 18 squared. So that means 18 times 18, which is 324, plus 5 to the power of 0, which is 1. But that means everything in here is to the power of 0. So if we look at that equation and say, hey, wait a second, I could have saved myself a lot of math work and just went, I know the exponent rule of anything to the power of 0 equals 1. So 1 divided by a negative 5 to the power of 0 is 1, which equals 1. So we have to make sure we're aware of the order of operations and also our rules of order of operations. So let's review. In review of this outcome so far, we've discussed 3 of the 5 concepts. We've discussed what is a power. And within the power, it means if I have 3 to the power of 5, I know that this is my base. This is my exponent. And the entire thing is called a power. And that means 3 times 3 times 3 times 3 times 3. Okay? This is called expanded form, which is also another word of repeated multiplication. And the answer to 3 times 3 times 3 times 3 times 3, did I say that 5 times? 3 times 3 times 3, I think, right, is, go in your calculator, we're going to hit 3, and then you hit your exponent button, which it could be x to the power of y or y to the power of x, and then you're going to hit 5 with this little 5, and you're going to get the answer of 243. Did you get that right? Hopefully you understood of what the power and a base is. We have to make sure that we pay attention to the role of the brackets, because brackets mean everything in here belongs to that power of 5. So that means that I'm going to have negative 3 times negative 3 times negative 3 5 times, and since it's an odd number, I'm going to get a negative 243. So making sure that we know the role of the brackets. We also learned that the base 10. So if I have the answer of 5 times 10 to the power of 6 plus 4 times 10 to the power of 5 plus 9 times 10 to the power of 3 plus 7 times 10 to the power of 0. If I was asked to write that in standard form, which means the answer, I could do this a couple of ways. Yes, I could put this all in my calculator. Okay. Know that 5 times 10 to the power of 6 is different, because that says 50 to the power of 6. That's a lot different than tells me that. So make sure we don't get that mixed up when we're writing that out. So if I wanted to know the answer to this written in standard form, I could do it, yes, in my calculator. I could plug it all in, find the answer. Or I could do it two different ways. I could say, all right, I have a 5 with how many zeros after? 1, 2, 3, 4, 5, 6. All right, I have a 4 with how many zeros after 5? So 1, 2, 3, 4, 5, and I put a 4 there. I go here, I have a 9 with how many zeros after? 3, 1, 2, 3, and I put a 9. I have a 7 with how many zeros? None, so that goes here. So in all, what's my answer? I line up 7, 0, 0, 9, 0, 4, 5. That's my answer. So that is the answer for this in standard form, and this is scientific notation, or base 10s. You could also do it a really fast way by saying, all right, what's that answer? I have 5 with 6 places. My next one is a 4 with 5, so I know that goes 6, 6, 5. Do I have anything with a 4? No, so that means it's a 0. 3 is a 9. Is there anything with a 2? Nope. 1? No. 0? Yes, it's a 7. So there's my answer. So that's in review. All right, order of operations for review. If I have the answer or the question, sorry, 2 times negative 3 to the power of 3, so bracket, minus 6 squared. According to BEDMAS, I do my brackets first. So that means everything in here belongs to the power of this 2. But I need to know what that everything in there is. So I start the BEDMAS process over and said, do I have any brackets? Yes, I have brackets in there, but these brackets in here mean everything in here belongs to this exponent. So I need to solve my green. Okay, so I go over here with my green. That green means negative 3 times a negative 3 times negative 3. Okay, and that exponent, negative 3 times negative 3 times negative 3 is negative 27. So I put that back in my answer, rewrite my question. Okay, big bracket, I have 2 times a negative 27 minus 6, big bracket, squared. Okay, next part in the BEDMAS, I'm still solving my brackets. I'm still solving this bracket, but inside the brackets, I want to find out what is 2 times negative 27. 2 times a negative 27 is negative 54. So then I go negative 54 minus 6 squared. Solve my brackets. So negative 54 minus 6. Remember, same signs add, different signs subtract. So they're the same signs. So same signs add, I'm going to get the answer of 60. Same signs, keep the signs different, keep the larger. So they're the same sides, so I'm going to add them, keep the sign. So I'm going to get the answer of negative 60 squared. Remember, I keep the brackets. So that means, last but not least, everything in here belongs to the power of 2. So that means a negative 60 times a negative 60. And I get the answer of 3,600. So that's the first 3 things on your checklist. So practice that, making sure you understand it, because now next we're going to involve the laws of exponents and powers in our next video. So good luck with the first 3 concepts. Check in to make sure that you're doing okay, and then go click on the next outcome and 9.1 for the next 2 concepts of this outcome. All right, thanks.